Okay, today's class is all about the conclusion to your practical investigation. This is where all the analysis is done, all the thinking happens. So we've got three sections to do. The first section is basically the response to the hypothesis, the response to your research question, and that's where you look at your data and you come to the basic conclusion of your investigation. Then we're on to errors and methodology, and finally we're looking for the overall validity and any extensions that might be good. So first of all, response to the question. Look at the data. Does the data support your hypothesis? Come to an overall judgment about that. So just looking back at my example, my hypothesis was that as the mass of fuel increases, the heat of combustion increases as well to become more accurate. What did I find? When I graphed my data, I could really clearly see the opposite. As more fuel was burned, the heat of combustion that was calculated was lower, reflecting greater heat loss from this apparatus. So it went the other way. My hypothesis is completely wrong. So start off with a really clear statement that the hypothesis is either accepted or rejected, and in this example it is clearly rejected. So what does the data say? What does this mean for my hypothesis? Start off with that. Don't bury it somewhere deep at the end. Then, once you've made your judgment, now you can relate it back to the relevant theory, especially that you used at the start. Now, I talked about how higher temperature might mean we might improve the quality of the combustion, therefore get more heat basically released in the flame. I've got to basically say, well, that didn't happen, and talk about that a bit. So I suggested that maybe there was more incomplete combustion, that there just isn't, if it burns faster, there just isn't enough oxygen. This is just a pure speculation on my behalf, but I'm relating it back to that theory that I put in my hypothesis. It doesn't have to be particularly profound, but just something to show that you're thinking about what's happened and what the implications are of that. Then I just made another point that if we've got basically that saying, that last sentence, if it's burning faster, the heat flow, the hot air will be rushing past the beaker more rapidly, so you'll get less heat absorbed. Just putting that in more formal language. So just coming up with a couple of ideas to try and explain what happened, try and relate it back to the theory that we know. So now it's time to post task 10, response to the question. Now to evaluate the data and methodology, look at the errors that are obtained. And the rubric asks us to evaluate random, systematic and procedural errors and discuss their implication on accuracy and precision. So I'm going to go through each of those in turn. First of all, random errors. That's due to the intrinsic uncertainty of the measurement. So this can be due to the equipment. We know that electronic balancers have an uncertainty of plus or minus, or the ones at school have an uncertainty of plus or minus 0.005. That's intrinsic to the balance. We know that when we read a measuring cylinder, we can judge it to roughly half of the smallest interval, i.e. plus or minus 0.5 of a mil. So these sorts of errors affect the precision of the method, how tightly clustered together they are. So I'm going to list one example here. I'll be expecting to see more than that on your reports. So I'm just talking about reading the thermometers here. It's a judgment. thing, so there'll be uncertainty as the individual reads that thermometer. And then I relate that to these random errors to their effect on the precision of the data. Of course, how do we reduce random errors? How do we increase precision? We repeat the experiment. We need at some point to include this discussion. Now, I think all of the data being used, the experiment was repeated 3 times for each iteration, each different condition. And so this will be a fairly stock standard comment that everyone will need to make. Then I relate it back to the fact that even though that I've got random errors, my data was really clear cut. They're not going to have affected the overall validity. Then we move on to systematic errors, which are errors that will be repeated every single time the measurement is made. So they can be caused by faulty equipment, poor calibration of equipment. They can also be caused by confounding variables, variables that should have been controlled but weren't. Now these will affect, systematic errors reduce the accuracy of the method. They will get you a result which is away from the true value and a similar type of result every time. They'll be away from the true value in a similar way each time it's repeated. Repeating it will not help. So again, I'm going to give an example of one systematic error. And this is one that I talk about a bit in my discussion of overall theory. And it's basically the difficulty of regulating airflow. We've got a heat shield which does that, but really a puff of wind can change your results quite significantly. So this is an uncontrolled variable effectively, and yeah, a systematic error. Procedural errors are flaws in methodology which result in an inability to measure what is intended. So a flaw in your method that makes it difficult or impossible to answer the question that you should. Now, my example is the mixing of water. Now we simply bung the thermometer in 1 centimetre above the bottom of the beaker. Now there's going to be a temperature gradient. The temperature is going to change right throughout the beaker of water. We can have no real confidence that the change in temperature that we measure is going to reflect the overall change in temperature of the whole beaker. So that calculation can never really be accurate, and that has implications for the whole point of the experiment. We should have stirred better, we didn't. So if you can come up with another example of a procedural error, that would be good. Now it's time to do poster task 11. Look at the 3 types of errors and try and find some examples of each. Remember to discuss, just make a statement about their effect on accuracy and precision. Now, the final section is an evaluation of the validity of the overall experiment and some suggestions for future research. So, validity. How well does the experiment measure what it sets out to measure, what we wanted it to measure? So we can look at confounding variables and limitations of the method. So in my case, I'm rejecting the hypothesis, and the data's pretty clear cut. However, there are serious limitations in the method, and I've already highlighted how oxygen flow, airflow is an issue, and that's something to include at this stage as well. So is there anything in the way that the experiment was done which makes it difficult to trust the overall results that we get? See if you can come up with an example of that or some comment around that. Perhaps you might think that there were no serious issues with it, that the results, the overall conclusion is perfectly valid. There's nothing wrong with that. Yeah, and I go on to basically my investigation is one of the ones that is designed to produce a better, more accurate heat of combustion, and it failed obviously. So that final comment is basically casting doubt on the use of this type of apparatus to calculate any heat of combustion. If yours was about something to do with the fuel, then it might well have been a perfectly valid investigation. And that leads us on to the final part of the section, which is just what extensions are suggested. So what further things can we look at? What do your results lead you to think about? So if you've talked about something to do with the chemistry, like the number of carbons, if you're one of the people who did methanol, ethanol, propanol, butanol, is there something else that you can investigate to do with differences in breaking carbon-carbon bonds, something to do with the number of carbons? Maybe the number of hydrogens is important as well because they both increase together. So just think about things like that. What's something else that could be investigated? So in terms of mine, which is a more procedural one, to do with getting an accurate heat of combustion, clearly there's something wrong with incomplete combustion. So that makes me think about, well, what actually happens? How does that combustion reaction work? What's actually going on in that flame? So that's something that I would be interested in investigating. Now, just to finish off with, we do need to include a references and acknowledgement section. References refers to published sources. So whether you used a book, whether you used an internet site, they all need to be written up in the references. So here I've cited the data book, because no doubt you're going to have used the data book, and a Wikipedia site, if you may have chosen that to find heat of combustion or other data that you may have used. So anything that you used, include that in your references. Finally, the acknowledgement section, any assistance that you received from someone else. Now, I'm well aware that I did provide assistance to most people at some point with hypotheses and data and that sort of thing, so I'd expect a acknowledgement of that. And anyone else who helped you, I've got absolutely no judgment if people help you with this. I've got no problem with that. I would just like to see their assistance acknowledged in this section. Okay, so do the final post task, and then once you've done those and I've marked them off, your job will be to put it together into an overall poster or report, which will be due first face-to-face class back at school.